Imagine you are floating in the dark just outside Earth's atmosphere. Below you, the planet glows blue and peaceful, cities twinkling like scattered stars. It looks safe. It looks permanent. It looks like home. But then you notice it. A flash. Silent. Instant. A beam of pure energy, traveling at the speed of light, already halfway across the galaxy. And it's pointed directly at you. You wouldn't see it coming. You wouldn't feel it coming. By the time your brain registered the light, every atom in your body would already be unraveling. This isn't science fiction. This is gamma-ray bursts, and they're real. The universe looks beautiful until you understand it. From Earth, space looks serene. Stars twinkle, planets drift. The Milky Way stretches across the night sky like a river of diamonds. We point telescopes at it and feel wonder. We send probes into the void and call it exploration. But something is wrong. The beauty is a lie. The silence isn't peace, it's emptiness. And every point of light you see is either a bomb waiting to explode, a monster waiting to feed, or a bullet already in flight. The universe was never designed for life. It was designed for chaos. And we're just temporary guests in a house full of predators. The first wave hits before you know it exists. Gamma-ray bursts are the most powerful explosions in the universe. In a few seconds, they release more energy than the sun will emit in its entire 10 billion year lifetime. They're born when massive stars collapse into black holes, or when two neutron stars collide and tear each other apart. The radiation they emit doesn't travel like light. It travels like a weapon. If a gamma-ray burst went off within a few thousand light-years of Earth and pointed directly at us, the ozone layer would vanish in seconds. Not degraded, not weakened, gone. The protective shield that took billions of years to form would be stripped away like paper in a hurricane. But here's the problem. We wouldn't know it happened until it was too late. Gamma rays move at the speed of light. There's no warning, no alarm, no evacuation. The photons arrive, and with them comes the end. DNA shatters, cells liquefy, the atmosphere ignites with secondary radiation. Everything alive on the side of Earth facing the burst dies within minutes. And this isn't theoretical. Astronomers have detected gamma-ray bursts from billions of light-years away. They happen, regularly. Somewhere in the universe, a star is dying violently right now. And one of those deaths could be aimed at us. But it gets worse. Let's say you survive the gamma-ray burst. Maybe you're deep underground. Maybe you're on the far side of the planet. You think you're safe. But here's where things change. The radiation doesn't just kill what's alive. It kills what's possible. The ozone layer is gone, which means the sun's ultraviolet radiation now hits the surface unfiltered. Photosynthesis collapses. The food chain disintegrates. Oceans turn acidic. The planet enters a slow, suffocating death spiral that lasts for centuries. And that's assuming the burst was far away. If it happened within 100 light-years, the radiation would be so intense it would ionize the entire atmosphere. Nitrogen and oxygen would react to form toxic compounds. Acid rain would fall for years. The sky would glow with eerie auroras as charged particles rain down. There is no shelter. There is no recovery. There is only the countdown. The invisible hunters are already here, but that's not even the worst part. While gamma-ray bursts are terrifying, they're at least visible. You can see the stars. You can track them. You can calculate the odds. Rogue black holes are different. These are black holes that were ejected from their home systems, cast out into the galaxy like cosmic exiles. They drift through the darkness, invisible, undetectable, hungry. They don't emit light. They don't broadcast their position. They simply exist, warping space-time as they pass. If a rogue black hole entered our solar system, we wouldn't know until Neptune started to wobble. By then, it would already be too late. The gravitational pull would disrupt planetary orbits. Earth's path around the sun would shift, subtly at first, then catastrophically. Seasons would break. Temperatures would swing wildly. The delicate balance that allows life to exist would shatter. And if the black hole came close enough? Spaghettification. Your body would be stretched into a thin strand of atoms, pulled apart by the difference in gravitational force between your head and your feet. You wouldn't die instantly. You'd feel every second of it. But here's the problem. Rogue black holes are impossible to detect until they're already inside the solar system. They could be drifting toward us right now, and we'd have no way of knowing. The sun itself is a threat. You look up at the sun and see warmth, light, life. But the sun is also a bomb. Solar superstorms, massive eruptions of magnetized plasma called coronal mass ejections, happen regularly. Most of them miss Earth. Most of them are harmless. But not all of them. In 1859, the Carrington event hit Earth. It was a solar storm so powerful it electrified telegraph wires, shocked operators, and lit up the night sky as far south as the Caribbean. If that same storm hit today, it would collapse power grids, fry satellites, and plunge civilization into darkness for years. But that was a minor event compared to what the sun is capable of. Superflares, storms thousands of times more powerful than the Carrington event, have been observed on other stars. There's no reason to think our sun couldn't produce one. If it did, the radiation would cook the atmosphere. Electronics would fail globally. The internet would vanish. Modern society would end in hours. And this is where things change. The sun isn't trying to kill us. It's just existing. Its violence isn't personal. It's indifferent. And that's more terrifying than any monster. The vacuum itself might betray you, but it gets worse. All of these threats, gamma-ray bursts, rogue black holes, solar superstorms, assume the universe stays the way it is. They assume physics remains constant. They assume the rules don't change. But what if they do? False vacuum decay is a theoretical phenomenon where the universe itself is unstable. Right now, space exists in what physicists call a false vacuum, a state that seems stable but isn't truly at the lowest possible energy level. If a bubble of true vacuum formed somewhere in the universe, it would expand at the speed of light, rewriting the laws of physics as it went. Atoms would cease to exist. Chemistry would become impossible. Life would be erased not by destruction, but by irrelevance. And here's the horror. You wouldn't see it coming. The bubble moves at light speed. There's no warning, no signal, no escape. One moment you're reading this. The next moment, the concept of you no longer exists. Some physicists think this might have already happened somewhere. The bubble could be on its way right now, and the only way you'd find out is by no longer being here to wonder. There is no safe scenario. You might think you're safe because these events are rare. You might think the odds are in your favor. But the universe doesn't care about odds. Asteroids strike Earth regularly. Most are small. Most burn up in the atmosphere. But one the size of a city would end civilization. One the size of a mountain would end the species. And we've only cataloged a fraction of the objects out there. Supernovas explode in our galaxy every few decades. Most are far away. Most are harmless. But one within 50 light-years would sterilize the planet. And we can't predict when or where they'll happen. Neutron stars collide, magnetars flare, quasars fire beams of radiation across galaxies. Rogue planets drift through the darkness, invisible until they're close enough to disrupt everything. Every threat is real, every threat is possible, and every threat is inevitable, given enough time. The final realization. So why are we still here? Because the universe is vast, because the distances are enormous, because the odds of any one threat hitting Earth in any given moment are astronomically small. But astronomically small isn't zero. And the longer we exist, the more the odds stack against us. Every second we survive is a second we've beaten cosmic roulette. Every breath is a victory against a universe that wants us dead. We look up at the stars and feel wonder. We send probes into the void and call it exploration. We dream of colonizing other worlds, of spreading life across the galaxy. But the universe was never meant for us. It was built for violence, for chaos, for destruction. And we're just temporary accidents in a cosmos that doesn't want us here. The gamma-ray burst is already in flight. The rogue black hole is already drifting. The solar superstorm is already building. The only question is, when? And when it comes, there will be no warning, no escape, no mercy. Just the silence, the dark, and the end.